Hello, this is Ashley Griffin. Today I'm going to be talking about how to predict car warranty purchasers using nearest neighbor data mining techniques. This project will be done in Weka, which I have open here. And let me give you all an overview about what the nearest neighbor technique means and how it fits into machine learning before we open up the data file. So nearest neighbor is a data mining technique that allows you to use existing data to predict an unknown output value of a new data instance. It's very similar to regression and classification in the sense that they are all considered supervised learning, but it's also similar to clustering model as they use the same Euclidean distance calculations, and clustering model is unsupervised machine learning. So let's go ahead and open up a file. This is a BMW training file from the IBM Developer Works website, and it has 3,000 instances in this data set and 4 attributes. So the first attribute is the income bracket. This shows how much that the individual earns, and it is divided into labels 0 through 7, which incrementally go up with the person's income. The next attribute is their very first BMW purchase and the date. These values are date values. Their last purchase, which is when they most recently purchased the BMW, and their response to a prior marketing campaign for car warranties. One would be if they did indeed get the warranty, and a 0 if they did not get the warranty. So let's go ahead and choose the nearest neighbor algorithm here. It's under classification tab. We're going to use our training data set, which we've just loaded. And under choose and lazy, we are going to use, whoops, not K-star, the K and N, which is nearest neighbors, and the K stands for the number of neighbors that you want to use in your data set. So let's go ahead and run this algorithm. And it looks like it is still processing. Okay. And now we are ready to look at the results. So it processed 3,000 instances, and with our 4 data attributes: income, first purchase, last purchase, response. It's evaluating the training data, which we changed it to, and the default is to use one nearest neighbor for classification. So in the summary here, correctly classified instances are 2,663, which is about 89% of the data set. So to me, that is very high. So this particular data set and algorithm worked very, very well. Almost 90% classification rate. In addition, incorrectly classified is 11%. And then there are some kappa statistics and standard error percentages here. The detail accuracy by class goes into a little bit more detail, such as the true positive rate, false positive rate, level of precision, among other measures. Similarly, in the confusion matrix, this shows the number of false positives and false negatives, and those that were actually categorized correctly. So here there were 76 false positives. And a false positive in this example would mean that our model predicted that the person would not buy an extended warranty, but they actually did buy the warranty. And for 261, here we see that these are false negatives, which would mean that our model predicted that the person would not buy an extended warranty, but they actually did. So this could warrant more of a cost-benefit analysis and see the difference between false negatives and false positives as well. So now if we click on choose, we can change the number of nearest neighbors. So let's change that to 2 nearest neighbors. And let's run that again. Looks like it is still processing for a bit. So the default is 1 nearest neighbor, but that can be expanded beyond the closest match to include any number of closest matches. So using the first nearest neighbor model, we correctly predicted customers 89% of the time who will or will not buy a warranty. So using 2 nearest neighbors, the model tries to find the 2 closest neighbors, weights their distance, and then averages the answer to a binary yes or no, since our outcome variable is a 0 or 1. So our results are in, and using the 2 nearest neighbor model actually was worse than the first nearest neighbor, and it was only 76% correct classification. Many more false positives here and false negatives as well. And so this example is quite interesting to me, and it reminds me a lot of online advertising and suggestions for similar projects such as on Amazon. And I imagine that Amazon's training data sets are very large because they have such a large customer base. So I imagine that the algorithms are very accurate, and in my experiences, they have been accurate. I think that Amazon is using this algorithm or something very similar when they're recommending products to us, and they choose anywhere from 1 to 15 nearest neighbors perhaps when they are recommending different products to us. So thank you all for your time, and I hope this was helpful. The focus on this project was on predicting car purchasers of warranties using the nearest neighbor modeling technique. In addition, regression models, clustering models, and classification models could be used within Weka, and they all answer different questions. So regression could answer the questions such as how much should a dealership charge for a car, which wouldn't be in this data set, but they could have other attributes to evaluate that question. Clustering could be used to mine data to compare the age of a car to the color of a car, so perhaps customers over 65 tend to buy gray cars. And classification, or using decision trees, could simply be used to determine the likelihood of a person buying a car. So again, thank you all for listening, and I will hope to talk to you later. All right.